Hey guys, it's Miss Johnson and I'm here to bring you the second part of section 3.2 from our book. Today we are talking about the least squares regression line. We are going to talk about how to find that line, how that line is calculated, and how it goes along with our scatter plots of our data. So again, we're looking in that big section of 3.2 that has 2 full pages of learning targets here. There's the second page of learning targets, so there's a whole lot of learning targets that happen in section 3.2, which is why we have it broken apart into 4 different pieces. So this is just piece number 2. So the LSRL, or in other words, least squares regression line, you will hear this referred to as LSRL quite a bit. The least squares regression line is the line that goes through your data, and it is the line that has the least area or the least amount if you square the data, or if you square the residual, I guess you could say, of each data point. So for example, this one that I just highlighted right here, here's my data point. Here's the point on the LSRL. This box, I'll put it in green so you can see it a little better. That green box is the square of the area. It's basically the area of the residual. If I was gonna make this residual, remember residual is that distance from the line down to the point. If I was gonna square that and add up the area of all the residuals, that is going to be the one that has the smallest amount of squared area is what gives us the line. So your calculator is actually going to go through and figure out what is the least amount of area if we square all these residuals. Part of the reason that we square these residuals is because some of these residuals are negative. So it doesn't make sense to just add them up and find an average. That's not how it works, because we'd be adding some negative values and we don't want to do that. We need to think of it in terms of distance. So we square the residual so that all of these things are positive. Okay, so it says the least squares regression line is the line that makes the sum of the squared residuals as small as possible. So if we're going to calculate this LSRL by hand, the first thing that we would have to do is find the mean of our x and the mean of our y's. So find x bar and y bar. Okay, then we would calculate the slope, because remember this is a line, so it's that equation y hat is equal to b sub 0 plus b sub 1 times x. So the two things that you're finding are the y-intercept and the slope. We would do the slope first. The slope is going to be r. Do you remember r? We haven't talked about r in a couple days. R is the correlation, that correlation coefficient. Okay, so that's coming back for us. R is correlation. So we would take the correlation, basically that's how strong is the association between the two variables, and we would multiply that by the standard deviation of y over the standard deviation of x. That's what S sub y and S sub x is. Then we would find the y-intercept by plugging in, we would now have our b, plug it in. We take the mean minus b times the x mean, the mean of y's minus b times the mean of the x's, and that gives us a. And then we can write up that equation. Graph the slope, graph the y-intercept. All right, so we're going to do this one time together. So go ahead and find your calculators if you don't have your calculator out yet. I'm going to put you're going to go into Stat Edit menu, and you're going to put your x values into L1 and your y values into L2. So I'm going to clear out my list. If you don't remember clearing out your list in your stat editor, you want to arrow up to where the list label is highlighted. So like right now I'm on L2 and my L2 is highlighted. I'm going to hit clear. Don't hit delete, because that deletes the whole list. But if you hit clear and then hit the down button, it clears out all the data from that list. I'll go over and do it for L1 as well. And now I'm going to enter in all my x values into L1. So 1, 3, 4, 6, and 8. I put all my x values in. It's important to put the corresponding x value with the corresponding y value, so I'm going to go in the same order: 2, 4, 3, 5, 7. So that data is in for my L1 and my L2. All right, you are already told that your correlation is 0.94. They gave that to us. Great, so I've got 0.94. I'm gonna go ahead and do my one variable stats. So if you hit stat and go over to calculate and then do one variable stats, if I do one variable stats for L1, I get a mean of 4.4. So this is L1. And then I need the S of X from L1. Now, it's a little bit tricky because we call this S of X because it's based on the data, but in your one variable stats, you actually want to look at the standard deviation of X, which is that funky sigma sign. So my standard deviation of X is 2.4 in this case. Now I'm going to do my one variable stats for L2. So go back to stat, go over to calculate, change your list to L2. The L2 is above the number 2. So if you do second and 2, you get to L2. And then I'm going to hit calculate again. My mean there, so this is L2. My mean is 4.2. And again, you're looking at the standard deviation. My standard deviation there is 1.72. Okay. All right. So if I wanted to calculate the slope, my slope is that B. That's where I have the 0.94 times the standard deviation of Y divided by the standard deviation of X. So type that into your calculator. You've got 0.94 times, open a parenthesis, 1.72 divided by 2.4, and I end up with a slope of 0.674 roughly. So my B value is equal to 0.674. Then I need to also calculate the A value. The A value is going to be, that is where we take the mean of the y's, 4.2, and I subtract the slope times the mean of the x's, which is 4.4. So in this case, my A value is 4.2 minus previous answer times, I use the previous answer option in my calculator a whole lot. So even though I rounded this up to 0.674, I actually arrowed up in my calculator and pulled the previous answer. It just makes it a little bit more accurate. So I get a value of 1.24 if I'm going to round there. So then my equation looks like y hat, because this is an LSRL, so this is a prediction equation. Y hat is equal to 1.24, and it's a positive slope. My slope is positive there. So plus 0.674 times x. So there's the equation for my line. If I was going to graph this, let me put my points on the coordinate plane. I'm going to say that I have quadrant 1 here. Here's my x, here's my y, and I'm just going to count by ones because I only need to go up to 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be 10 there. And I'll do the same for the y's because again, I only need to go up to 7. So 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10. All right, so now let's graph those points. If I graph the points, I'd have 1, 2, I'd have 3, 4. Sorry that I entered that or drew that dot unnecessarily. And then 4, 3, which is right there. 6, 5, and 8, 7. So this is 8, and then all the way up to 7. All right, so there's my actual data. Those red points are my actual data. Now I'm going to go ahead and graph my LSRL on the line. One thing that you can always do, this is always a point on your LSRL. If I created a point on my LSRL, I'd have 4.4 comma 4.2. The mean of your X and the mean of your Y is always going to be a point on your LSRL. So 4.2 and 4.4, I go over to 4.4 right about the little under halfway to the 5. That's 2, that's 3, that's 4.2. So I know that's 1 point on my LSRL. The other point that I know that's on my LSRL is the y-intercept. So if I go to 0 and 1.24, I'm right about there. And you really only need 2 points to make a line. So if I connect those 2 purple points, there's my LSRL. Now, the beauty of the fancy machines. We have fancy machines, your TI-84 or 83 if you're using an older one. Your TI-84 is going to graph this, or will create this LSRL option for you. So we already did entering the data into L1 and L2. Now I want you to try and go back to your calculator and go to Stat, go over to Calculate, and then option 4 is LinReg. I bet you can figure out what that stands for. Linear regression. This is going to put the linear regression line on your home screen. So if I just do Stat, Calculate, option 4, and hit Enter. Ooh, I need to make sure I check my list because I had L2 in for both. So X list is L1, Y list is L2, and then I want to calculate. It gives me that equation. So I see the y equals ax plus b. They have it written in mx plus b form, which is fine. We can flip it and do it in the stats form. But I see that b value of 1.24. I see that value of 0.67 for the slope. And it looks pretty similar to what I calculated on the previous slide. But the best thing about this is we also have an option to put it in our y equals menu. If we want to put it in our y equals menu, that's going to put it straight on our graph. So you're going to enter your options into L1 and L2, and then you want to enter Y1. This is where you see, this is where if you're looking at a calculator that has that stat wizard, you see the store regression equation. If you see that option that says store regression equation, here's how you get it into your Y1. So when you're on that store regression equation option, you're going to hit the vars menu, you go over to Y-vars, you hit on function, and then you hit Y1, and that'll put it in your first option. It's still going to take you to the home screen to show you what the equation looks like, but then if you go to zoom and you go to 9, you will see your regression line. The other thing that is going to be important for you to do is to check your stat plot, because you can put the scatter plot on your stat plot just like we did in lesson 3.1. So if you do stat plot, okay, go into your stat plot menu, go into plot 1, go to that scatter plot window next to type. You want the one that looks like a scatter plot. It's the first option on mine. Your X list is going to be L1, or wherever you put your X data. Your Y list is going to be L2, and then you can hit, you'll have this, you'll have the regression equation, and you'll have the stat plot, and if you do zoom 9, it'll graph them both. So give it a try. You should be able to hit zoom 9 and see both your scatter plot of those 5 points and also the LSRL that goes through the middle of them. One thing that you need to check, when you did your LinReg options, you should have seen R and R squared. R&R squared only show up when you have your diagnostics turned on. Now, if you've never done this before, your diagnostics might not be on. So this is the process to turn your diagnostics on. You only need to do this one time, unless for some reason you have to reset your calculator, then you might have to do it again. But once you turn your diagnostics on, they just stay on until you either reset your calculator or turn them off yourself. So you would go into the catalog, you'd go to hit the D, go down to diagnostics on, you'll hit enter to put it on your home screen, and then you'll hit enter again and it'll say done. When you see done, then you can go do LinReg again and you should see R&R squared show up. All right, so when we calculated the LSRL of the 4 points that we found, I got a, let me go up and just enter it into again so I can see it on my screen. I got an LSRL of y hat, because it's a prediction equation, is equal to that 1.25, it looks like roughly 1.25 plus 0.671 times my x. My x does not have a hat. Notice that. Your x is going to be an actual value. The prediction is the y. So x doesn't have a hat because x is an actual value that you're plugging in. X is explanatory. So those are values that you're picking out of the window, the range of data. The y value is what the prediction is. All right, so then let's just talk briefly about how to determine if a linear model is appropriate, okay? We can do something that's called a residual plot. The residual plot is going to show us how big is the distance between all of the points. So I'm going back to that F-150 example that we talked about yesterday, where we had the 14 F-150s and we're looking at their used prices. This is the data graphed, and we looked at this graph yesterday, and this was the residual line that went through it. Now, based on that residual line, we calculated what's called the residual plot. So on the residual plot, what it graphs is all of the x values with the residuals. So your data is still x, the miles driven, but now you're looking at the residuals. So what's happening here is you see, was the residual positive like these, or was the residual negative like these down here? Because you're going to have some residuals that are positive and some residuals that are negative. Now what we want is we want to see the most random scatter that we can. Random scatter. Our residual plot should show random scatter. If we see random scatter, that means that our linear model is good. If we see a pattern of any kind in the residual plot, that means our linear model is bad. That means that this is probably a data set that should be using a different model, like exponential or quadratic. So one of the first principles of data analysis is to look at the overall pattern and the striking departures of the pattern. A regression line describes the overall pattern, but we see departures in this pattern by looking at the residual plot. So the residual plot is a scatter plot that displays the residuals on the vertical axis with the explanatory variable still on the horizontal axis. Okay, so here are some residual plots that are maybe not a great model. So it says a residual plot magnifies the deviations of the points from the line. This was our data. If you're looking at this data right here, okay, that's the X and the Y of the data. See, the LSRL is going through there. Look at that nice, pretty curve. There's a really nice, pretty curve to our data. It's a very obvious curve. It's very obviously not linear. When it is very obviously not linear like that, check out the residual plot. Okay? The residual plot is a really nice, pretty curve. That's bad. That once again is telling us that it is not linear. This is not a linear model, and a linear model would not be appropriate for this data set. Okay, it says the residual plot should show no obvious patterns. You want to see random scatter. Some above, some below, none too far away, no clusters, no curves, nothing. You want to see random scatter all over like you're looking up at the stars at night. So the residuals should be relatively small in size, or in other words, close to zero. Okay, that's the other thing to think about when we're looking at a residual plot. All right, so how to interpret a residual plot. To determine whether a regression model is appropriate, look at the residual plot. If there is no leftover curved pattern in the residual plot, then the residual model is appropriate. Yay. If there is a leftover curved pattern, consider using a regression model with a different form. So this could be exponential or quadratic or something else, geometric. Okay, so there's a lot of other models that we can use other than just linear. So that recall, we're going to think back to that Ford F-150 example. Here's the LSRL. Okay, that was the LSRL that was given for us. It says, for this model, technology produced the following residual plot. So here's your residual plot. Now decide, is that linear model appropriate? Does it look like that residual plot has a good random scatter going on? In this case, I would say yes. Yes. The linear model is appropriate. Okay. The residual plot shows no departures or no patterns from the residuals. Okay. So now let's talk about making a residual plot, because this is where things are going to be a little bit different. You start off the same. You enter your data into L1 and L2. You then have to calculate the regression equation, where you go to Stat, Calculate, Option 4 for that linear regression. It just puts it on your home screen. Don't delete it, just leave it there. When you go to your stat plot, you're going to go to Stat Plot 1. The Y list is going to be resid, okay? And the way we get resid, so your X list is still going to be your L1. But now your Y list, you want to change to resid. And the place you get resid is you hit second stat and you go all the way down to the bottom. Second stat is that list option. And then you can do zoom 9 to graph it, okay? We are going to attempt to plot some of these residual plots throughout your homework assignment. If you need calculator help, we can work on some of that stuff together. We can do some examples together, and we have 2 more parts to chapter 3.2, so just hang tight because we're going to be using residual plots a couple more days. So that takes us to the end of our notes for part 2 of section 3.2. And if you have any questions, let me know. Otherwise, I will catch you for part 3.